Yeah,
I was almost on. I'm better.
2, number
I don't
1.
like you.
Yeah, fuck.
Any others? Those of you that need to still finish this test, this might help refresh some of your memory.
So it's not working today.
I know, sadly.
Okay. So for number 1, we have to factor it completely. We can start with a GCF, see if there's something we can divide out of each one. Is there? 3x, 3,
I'll go to national
and
math.
x.
Oh, when I'm working.
Really?
I'll be the register.
Type.
Guys, focus. So that would leave us with x squared minus, we're dividing each thing by 3, so 4x plus 3. And then because it says factor completely, we have to double check, can we factor this anymore? So it is a trinomial where we have a equals 1.
Wait, I don't know if I know you.
If we were to find two numbers that multiply to be 3, this is just 1 and 3.
What?
Is there a way I could make this -4 if I added or subtracted? -1. Right? This -1 and +3? -1 minus? -1 and -3. So if I change that, then I have x minus 1 and x minus 3. So now this is factored completely. There was a GCF. We could also factor the trinomial. Questions on
I
that
was
one?
hooping too hard this morning.
You were playing this morning? Type shit.
Okay.
Are you weight training first thing?
Then for number 2, give the direct variation equation for the point 1, 2. So direct
Surprise.
is y equals kx.
It's burgers.
And to figure out our direct variation equation, guys, stop talking, please. Put 1 and 2 into x and y. Solve for k. Divide this side by 1. That wouldn't really change anything. So that 2 equals k. And then to write the direct variation equation, just replace 2 in the original equation. Any other questions on the short bank? We're going to be doing a lot of stuff in these notes today with our calculator, so go grab that if you don't have it. Talk out of your writing. So I mentioned that we're starting quadratics last class. All quadratic equations, except for the ones we were doing last class, are written in the form y equals ax squared plus bx plus c. You saw a lot of that when we were factoring. When graphed, a quadratic equation creates a U-shaped curve called a parabola. And then to the best of your ability, I want you to draw a rough sketch of these two. Doesn't have to be perfect. Just make sure you have some U shape that's facing up, and that you have a dotted line going through the middle, and a point at the bottom, and call it the vertex. And then the same thing for the other one, but flipped upside down. If our a value, the number in front of our x squared, is positive, that's going to tell us the parabola, the U shape, is facing up. If that value is negative, the parabola is going to face down. So if you think about all the times we were factoring and we had positive a values, those were quadratics or parabolas that were facing up if we had graphed them, and the negative ones face down. Then we have some new vocab terms. axis of symmetry. This is the vertical line that divides the parabola into two equal parts. So that's the line you just drew. That's your axis of symmetry. And we write that as x equals whatever that number is. There is a formula to find it, so I'm going to show you how to do it algebraically, and then I'm going to show you how to do it in the calculator. Algebraically, you're going to use this. X equals negative b over 2a. And then another new vocab term, vertex. It's going to be an ordered pair, x, y, as we saw on the parabolas that we graphed. This is the turning point of the parabola. Usually it's at the very bottom or the very top. When the vertex is the lowest point, this is called a minimum. And when the vertex is the highest point, it's called a maximum. Do you need to move that? So once you have all that done down, we're going to go through just some examples doing like a rough sketch of what the graph would look like. Do a couple algebraically, and then do a couple in the calculator, finding the axis of symmetry, finding the vertex, and then we will actually graph it. We're going to start with example 1. So the order in which we do this doesn't really matter. But I can look at this example. The a value in front of your x squared is invisible, but there is a 1 there, which means it's positive. And if it's positive, we know this is going to face up or down. Up. I'm just going to put that so we know for later. Then algebraically, to find our axis of symmetry, we need that equation from here. I'm just going to rewrite it down here. X equals negative b over 2a. If you want to label your variables in your equation, you can do that. This one is a, this is b, this is c. You don't really need c right now. But to do this, we're going to put our a and b values into this, exactly as is. So x equals, our b value is 8, but we have to include this negative. And then over 2 times our a value is 1. Then we can simplify that.
Is that a 1 in the parentheses?
Yes. It looks like something else, but it is 1, yes. So if we simplify that, 2 times 1 we know is 2. Negative 8 divided by 2 is negative 4. So we know our axis of symmetry is going to be at x equals negative 4. Then to find our vertex, the x we just found, that's going to be part of it. But to find the y part, we have to take this negative 4 and put it in for every single x here. So use parentheses, and you can put this on your calculator all at once. So negative 4 in parentheses squared plus 8 times negative 4 in parentheses plus 15. What would that y value be? Negative 1. So that's going to be the other piece of the vertex. Then our rough sketch. Go ahead and draw x and y axes. We can draw in our axis of symmetry at what would be negative 4. Just draw a dotted line. 1, 2, 3, 4, or maybe somewhere here. These are not going to be perfect graphs. They're just rough sketches. You're going to have a vertex point at negative 4, negative 1, so along that line at negative 1. We know this is facing up, so we're going to draw a rough sketch of a U that would be facing up. Make sure you have arrows on both sides. Do you have any questions about how we found any of that information? Let's do the next one. I'm going to go ahead and label my A, my B, and my C, and I'm going to rewrite that equation so I'm not flipping back and forth. X equals negative B over 2A. Our A value is negative, so which direction is the U going to face? Down. Down. I'm writing that for later. So let's go ahead and find our axis of symmetry. Same thing we just did before. It's going to be x equals negative 10 over 2 times negative 1 in this case, because our A value is negative 1. And then simplify that. Should be positive 5. So that would be our axis of symmetry. X equals positive 5. Then we can use that to find our vertex. So we're going to put 5 in every time we see an x in our equation. So negative, and then in parentheses, 5 squared, plus 10 times 5, minus 23. Anyone need to see that one in the calculator?
Yes.
Okay. So I would type it in using the negative, and then parentheses, 5 parentheses square outside of that, plus 10 times 5 in parentheses, minus 23. Then we can draw our rough sketch. Go ahead and draw in your axes. I kind of confused my space. Our axis of symmetry is going to be at 5. I'm going to redraw this so I have a little bit more space on this side. Have some dotted line at 5, and we'll have a vertex point at 5, 2. somewhere along that line. And we know this is facing down, so draw a U that's facing down with arrows. Do we have any questions on that one? When we get back, I'll show you how to do some in a calculator. I'm gonna show you how to do, we're gonna skip down to 8 and 9. Is that what I'm gonna do? Yeah, sure. 8 and 9, and then we'll do those two in the calculator. And then any others from this that you guys want to see, do go over algebraically or in the calculator, and then we'll move on to graphing. So, for this one, we're going to reset our calculators first. Hit second plus 712. Reset the calculator. Second plus 712. And then we're going to go into y equals at the top. And we're going to type in number 8. So negative, make sure you have an x, and then square it, plus 4x. Over, make sure you put this in your calculator. Okay, now you can graph this, but that's not really what we need. We need to go to a table. Wilbur, go back to your seat. Quickly. So hit second graph. And you're going to get a table. In this table, your vertex point is going to be wherever you see like repeating numbers. So here, I'm going to scroll up a little bit. I see negative 12s, negative 5s, 0s, 3s, and then the 4 in the middle, the 2, 4 in the middle. That 2, 4 is going to be my vertex, because everything else is going to be the same kind of around it. So anytime you look on the table, you're looking for where is the middle of a bunch of repeating y values. So that would be your vertex 2, 4. And because you know your vertex already, you know your axis of symmetry, because it's going to be that x value, x equals 2. And you would say that you did this in the table as your work. And then we could sketch it from here. So we know the axis of symmetry is going to be at 2. So draw that vertical line, dotted vertical line at 2. Draw your vertex at 2, 4. Would this face up or face down?
Down.
Down. So draw your U shape facing down.
Wait, when is there not school?
Monday. Why?
Oh, there's not school Monday?
There's not school Monday. We're going to do another one in the calculator. If you did want to see this graph, if you hit graph, you could see the actual shape, but we're not doing that right now. Questions on how we do that in the calculator?
Which question
No. We just did that because there's so many things have been going on the calculator. Alright, so then for number 9, let's do the same thing. Go back into y equals. And you can really keep the x squared, or you can clear the whole thing out. So I'm just going to delete the negative. The delete is right next to mode. And just change this to negative minus 3. And delete the x again. You could also just clear out the whole thing and type the new thing in. Again, go back into your table, second graph, and look for where you see repeating y values. Where is the middle of that? Zero, negative 3. So we want that whole thing, the x and the y. Because that would be our vertex. Which means our axis of symmetry would be what?
0.
X equals 0. And we could draw in that sketch. Since the axis of symmetry falls on your y-axis, you could just kind of draw it on top of it. And then we have a point at 0, 3. Would this face up or down?
Are those burgers messing with my stomach?
I don't know. Shouldn't be too.
Awesome. They're really good.
It's negative fucked up.
You're right.
How bad?
I was like rumbling. So.
Bro, good luck.
I just feel
Still facing up, just have to
I feel faded off the school burgers.
You need to get some water.
I'm scared.
So you have to put that you did it in the table, otherwise you don't have work. Questions on that? Look through the other problems, numbers 3 through 10. Find any of those we want to see on the same page, either algebraically or in the calculator.
This is so hard.
Yeah, those are hard. Why are you hitting on them?
No, I'm hitting on the pants.
Or
Yeah.
algebraically or in the calculator. Algebraically, okay. While I'm doing this algebraically, if you still want to do it in the calculator, that's fine, because you should get the same thing.
You're gonna blow this thing?
Probably not. I mean, I can.
I'm going to write the,
So,
we
you
wrote the
working?
equation up top. So number 4, if we're doing that algebraically, we're using our x equals negative b over 2a. I'm going to label these as a, b, c. And that would look like negative b, which is negative 8, over 2 times a, which is 4. And simplify that. What would your axis of symmetry be? X equals negative 1. Right? And then again, algebraically, to find your y value, you're putting this back into all your x's. Make sure you're using parentheses if you're doing it algebraically. Thank you. What is that y value? 25, negative 25? I don't think it's that high. That sounds more right. Yep.
This?
Were you doing that algebraically or in the calculator?
Is it
Negative 1, negative 5.
Negative 1, so this would be
Oh,
1.
I
see what it did. Okay.
Okay.
Yeah, I see it. Alright, so then go ahead and draw that rough sketch. At negative 1, negative 5. Is that facing up or down? Up. Any others from this page that we want to see you go over, have questions about before we actually graph? Okay. What's nice is it's really going to be the same things, but we just have a couple extra things that we got to talk about on the next page. So go ahead and go to the next page. With this, we're going to fill out the table of values, so then whether you do that algebraically or in the calculator, you have your values to graph anyway. So let's do this first one in the calculator, x squared. Go ahead and put that in y equals. And go into the table. And find the middle.
0, 0.
0, 0. So your axis of symmetry is x equals 0. Your vertex is 0, 0. To fill out your table, you want to start with your vertex in the middle. And then your x's, you can go backwards and forwards. And then you can use your table from your calculator to fill out the rest of the y's. So that was 1 and 4. Let's go ahead and graph this first, and then we'll talk about these two. So graph those 5 points on your graph. You'll see that they kind of repeat. That's what quadratics do. They are even on both sides of the axis of symmetry. You won't actually see the axis of symmetry, but you're welcome to draw it in, the vertical line. You don't have to draw it in though. You do need to follow the points, connect the dots to make that U, and draw arrows at the end. If I were looking at this, I can see my A value is positive, so it should be facing up, so that matches. Right? And then domain and range, you may remember this from Algebra 1, you may not. So domain, you're talking about all the x's. So if I was looking at this, and if I was looking at all the x values, this is going to keep going up and left. So all of these x values will eventually get hit, and it'll go off the page, off the graph, off the board. Same thing to the right is going to keep going up and right. So all the x's are going to get hit, which means your domain starts at negative infinity and goes to positive infinity. For a quadratic, your domain never changes. That will always be your domain. Your range, though, that's different. So your range is your y values. You're looking lowest to highest. So the lowest point of this entire graph, if you want, you can draw a line where the lowest point is. So I know there's nothing below this, so it's going to start at 0, your y value of 0. And I know this keeps going up, so your y values keep going up and up and up forever to infinity. So this is going to start at 0 and go to infinity. You may also see it like this. You can either say it starts at 0, it goes to infinity. There's a bracket here because it's included. Or everything is greater than or equal to 0 with your y's. Questions so far? another one. Let's do number 3. So we have a negative example. Go ahead and put number 3 into your calculator. And then go into the table and find where your y values repeat and find the middle. You may have to scroll up. Where is the middle of that? -4, -1. So that's going to be your vertex. Your axis of symmetry is what? X equals -4, yep. And then you can start with that point in the middle of your table and fill out the rest. I know this is going to go back to -5, back to -6, forward to -3, forward to -2, and then you can grab the other values from your table. So this would be at -2 and -5. And you can graph those 5 points. So if I'm looking at that and comparing it to the equation, it has a negative a value, so it should face down. And it's going to look something like this. Remember that the domain is not changing. It's going to be negative infinity to positive infinity. Sorry. But your range, if we're looking from lowest to highest, since this is now flipped upside down, this is going to keep going down forever and ever towards negative infinity. And then where's your highest point? -1. So this is going to be everything below -1. So you can say y is less than or equal to -1. Or we can say this starts at negative infinity and ends at -1. Either or.
Can I get water real quick?
Yes. Do you have any questions about how we just graph that? Louise, phone away. Right. Look at other questions. We skipped over 2 or the back of this, 4 through 10. Any of those we want to see you go over, have questions about. Six. Alright, so let's go ahead and graph 6. Go ahead and put that in your calculator. Y equals -x² minus 4. Go into your table, find where your y values repeat. You may have to scroll back down. Where's the middle?
0, -4.
0, -4. So that's our vertex. Our axis of symmetry is
X equals 0.
x equals 0. I'm going to put that in the middle, 0, -4, and fill out the rest of the table. So going backwards, I know it's -1, -2, forwards, 1, 2, and then we have -5 and -8. We can go ahead and graph those 5 points. This should face down. Now, as we're practicing, some of these graphs will allow you to have more than just 5 points. You can plot as many as you want, but you should make it even so that you can see the same number of points on both sides if I were to draw my axis of symmetry. You could do more than 5, so you could have like 3 points on each side, but you should have at least 5 points. Domain is the same, -infinity to infinity. This is pointing in the same direction as the last one. So this is going to be everything below -4. So y is less than or equal to -4, or -infinity to -4. Any other questions we want to see you go over, have questions about? Now, this can be done algebraically, what we were just doing, but what you would have to do it algebraically to find your axis of symmetry, do it algebraically to find your y value, and then keep putting in each of these x values to find each of these y values. So it can be done, but it's a lot of work. Any other questions we want to see you go over, have questions about that? I want you guys to do one graph, fill in all of the things, axis of symmetry, vertex, domain, range, table, and the graph. Get it checked, and then you guys can practice either Delta Math or more of this. I want you guys to try number 10. So do number 10 and then raise your hand, get it checked, and then time is yours to practice.